Good afternoon, children. Hope you all are fine. Welcome to today's class. Today we are going to start chapter 3 matter. But before proceed, I want to tell you something that three copies are provided. Three copies are there with you. The thick one, I think that is 96 pages that you will be using for writing the question answer from the worksheets. Okay, so 96 page copy that you will in that copy you write the question answer from the worksheets, and another thin copy is there that is I think 32 pages that you can use for the question answer or to give the test, revision test, whatever revision test will be given, that answer you will be writing in that copy. Okay, and another copy is there that you keep along with you. Afterwards we will be using that. Okay, so now you are using two copies, the thick one, 92 or 96 pages, that you are using for writing the question answer from the worksheets, and the thin copy, which is of 32 pages, that you are using for writing the answer of revision test. Okay, hope it is clear now. And I want to remind you again that if you have any query, you send the question through your email. Okay, otherwise you will not receive the answer. Okay, the answer will it will go to you if you send. So student, provide your proper email ID so that the answers can reach to you. Okay, and for better sound quality, please use headphones. Okay, so now let us start. See, these are our points to be discussed today. What is matter? We will discuss that first. Then difference between atom and molecule we will be discussing once again. Then characteristic of particles of matter, and then we will be doing some activity to prove the intermolecular space between particles of matter. Okay, and then after that, states of matter, different states of matter, that we will be discussing. Okay, so let us start the first one. What is matter? Matter is something which have some mass and which occupy some space. So these two things should be there in a matter. It must have some mass and it will occupy some space. So many matters are there. Suppose the whiteboard which we are using, that is a matter. The pen which I am using to write, this is another matter. Both of these two are having some mass and it will occupy some space. If I keep it somewhere, it will occupy some space. So these two we can call as matter. Any other matters are also there around us. Many matters are there, so that also you can identify through these two characteristic. Okay, these two are the property of matter. Okay, and along with these two we can, another thing is there, that is the matter will be we can perceive it by our senses. Okay, we can feel it through our senses. We can touch it, we can feel it. Okay, so this is matter. Now let us once again just recapitulate atom and molecule. This already we have discussed in our previous chapter. Atom is, suppose any matter, take any matter, suppose hydrogen. Okay, hydrogen is a gas, it's an element. Now as we are writing H2, it's having two atoms. Okay, this is a molecule of hydrogen, By H2 we are representing one molecule of hydrogen. Now if we break it, we will be getting two atoms of hydrogen. So these are two atoms of hydrogen. Now this atom, that means what is atom? Atom is the smallest particle of an element which will carry all the properties of that element, but it cannot exist independently. So atom is the smallest particle of an element, or any of an element only we will say, okay. And it in this atom, in that atom, it will possess all the property of that particular element. So all these hydrogen atoms, in this hydrogen atoms, all the property of hydrogen will be there, okay. Whereas molecule is when these two atom will get together with a bond. This is the chemical bond we will say, okay, in between the two atoms, as atom cannot exist independently. Now molecule is again the smallest particle of any substance, which will possess all the property of that substance, but it can exist independently, not like the atoms. Atoms cannot exist independently, whereas molecule can, because there will in between the two atom there is a bond, and through this bond they will form the molecule, okay. They will get together to in this manner the atoms will get together and they will attain the stability, okay. So hydrogen molecule will be this, when two atoms of hydrogen will be bonded together with the chemical bond. Now this is the molecule, and if we draw this atom without the chemical bond, then these are hydrogen atoms. So this is the difference between atom and molecule. Let us take some other example. Suppose water. Water is H2O, okay. Now if we go to the structure of water, we will get this, okay. So one oxygen atom and two hydrogen atom. Two hydrogen atoms are bonded with the oxygen through this chemical bond, okay. Now see, if we break the water molecule, this is the water molecule together, oxygen and two hydrogen atoms. If we break it, we will be getting three atoms, two hydrogen atom and one oxygen atom, okay. Now these atoms, they cannot exist independently, but when they will be bonded together with this chemical bond, now this molecule having an existence, okay. So this is the difference we can say as this is the difference between atom and molecule we will be saying, okay. Now we will be discussing this characteristics of particles of matter. So for this, let us take an example. Suppose this is a piece of iron, okay. It's an iron block, suppose. Now if we see this properly, we will be getting that it is composed of so many particles, okay. So these are the particles of iron, we will say, or any matter. Now for these particles, what are the characteristic of these particles? All these particles of matter, it may be of solid or liquid or gas, any type of matter may be there, but the particles possess some kinetic energy, particles possess some kinetic energy, and because of this they will be having a random motion between them. Okay, though this kinetic energy is different for different kind of matter, and accordingly the movement, which is the movement between the particles, that will be different because of the kinetic energy. If kinetic energy will be more, then the movement will be less. If the kinetic energy will be more, then the movement will be more, and if the kinetic energy will be less, then the movement will be less. For solid, here we have taken iron, so this is a solid. So for this, kinetic energy is less, that's why the vibration, these particles will vibrate. Okay, there only they will remain in this position only, but in that position only they will vibrate in this manner. Okay, so without changing their position, they will remain in the same position, but they will vibrate. So this motion is called random motion. Okay, this random motion is less for the solids, as these particles are they are in closed manner, they are packed properly. Okay, tightly packed, that's why this movement will be less for them. Okay, and for gases we will see, as in gaseous molecules, as in gaseous substances, the particles are not closely packed in this manner like solid, so the movement or kinetic energy will be less, will be more high. Okay, for gases, kinetic energy will be high, so the particles will move very fast, or the random motion will be highest in gases. Okay, that again we will be discussing afterwards. Next, in this particles, in this particles of iron, we can see there are some gaps in between. See, in between two particles there are some gaps. These are the gaps between the particles. So these gaps are called intermolecular space. Okay, in between the particles a gap is there, that's why these are called interparticular space or intermolecular space. Now this space is different for different kind of matter. In few matters, there are in solids we will see the gaps between the particles are very less, because the solids are closely packed. But for liquids and gases, accordingly the space will increase, because they are less closely packed. Okay, so this gap between the particles, these are called intermolecular space or interparticular space. Both are same. Okay, in between the particles, that's why interparticular or molecular space. Okay, so these are called intermolecular space. And in between the particles there are some attractive force. In same matter, if the force is there, if we consider the force in between the same matter or same substance, we will say, then it is called cohesive force. The force in which will act between the like particles or same particles, we will say, this is called cohesive force. And this force between the particles, this is also called interparticular force of attraction. Okay, this force of because of this force of attraction, the particles will remain close to each other, they will remain together. This interparticular force or intermolecular force also we can say, this is highest in solid. That's why the solid in this iron in this piece of iron, we can say, you can see this, the molecules or the particles are very closely packed, very tightly packed. They are just together. Okay, they are very close to each other. As the force of attraction is more, then the particles will be more closer to each other. And if the force of attraction will be less, then the particles, there will be lot of gap between them. Okay, so if two things are there for particles in this in the structure of matter, we will say there are two main thing, that is intermolecular space and intermolecular force of attraction. If the force of attraction will be more, then there will be less interparticular or intermolecular space, and if force of attraction will be less, then the interparticular space will be more. Okay, now in between the particles, the intermolecular space is there. To prove that, there are some very easy activity or experiment which you can do at your home also. So how we will do that? Take a glass of water. In a glass we will be taking some water. Okay, see, these are the glasses fill up with water. Now add some 1 spoon of sugar in it. Okay, now sugar, this is another matter. And in the sugar we were having some sugar particles. The sugar which we are adding, these are sugar dust is there, and that means these are having some particles. Now before adding the sugar, we will be noting down the level of water. Suppose up to this the water is there. Now after adding the sugar, we will be stirring this solution, and then we will again check the level of the glass of water. We will see after adding the sugar, the level will remain the same only. Okay, there are no increase of the water level after adding the sugar. So how is it possible? If we take a close look in this solution, sugar and water solution, let us draw the water particles like this. So these are water particles. Now when we are adding the sugar particles, as these are very small particles, so they will be spreading in this interparticular space of water molecule. There are a lot of space in between the particles of water, and in this space the sugar particles will adjust themselves. Okay, so as they are adjusting themselves in this interparticular space of water, so there will be no rise of the water level. So this experiment easily you can do at your home. So do that. Instead of sugar we can use salt also. The same effect we will be getting. Now to prove the same, we can do another experiment, and for that we will be taking some stones or pebbles in a container. Okay, so let us draw the pebbles. These are the pebbles. Suppose now in this add some salt. So as salt particles, this with this blue I'm drawing the salt particles. As the salt particles are small in size, so like the sugar particle in this first activity, in the first experiment, the salt particles also, they will adjust themselves in between the particles of the pebbles or stones. Okay, so in this case also we will be seeing there is no rise in the level of pebbles. So up to a certain limit there will be no rise of the level of the pebble, as the salt which we are adding, they will get adjusted in between the interparticular or intermolecular space of the stone or pebbles. Okay, the same experiment we can do with this. These are the stones and this blue particles, these are salt. Okay, instead of stone, if we use small glass marbles or glass balls, and instead of salt if we use sand, the same effect we can see. Okay, so we will see from this experiment, we can see that if the particles are small in size, then more particles will be they can get into a space. Okay, if the number of if the particles will be the size of the particles will be less, then lot of particles can get adjusted in between them. Okay, so from this we can easily identify, we can easily see that in between the particles intermolecular space is there. Now come to this states of matter. So there are three states of matter generally: solid, liquid and gas. Other than this three, there is a plasma state and one is Bose-Einstein concentrate, but that is not our concern now. Okay, so we will be discussing these three only. So states of matter in detail we will be doing in our next class. Okay, so student, this is all for today's class. Hope you understood this. If not, if we are having any doubt, any query, specifically in that portion, you just mention where you are having doubt, and you as you are doing, you just through your proper email ID, you send the query, ask the question and all. Okay, this you can do. And at the same time, whatever materials will be provided with this, you just go through this line by line. This is very much important. Line by line you have to read the book, though you have not got the book. Hopefully soon it will come and you will be informed accordingly, but till then the study material which I am giving to you, that you do that you read properly, and at the same time worksheets which along with the study material, whatever worksheets I'm giving, that you solve properly. Okay, and you will be writing the answer in the classwork copy. Okay, and for test you will be using the test copy. Okay, so this is all for today. Have a good day.